Hi everyone, good morning. Thank you for joining and welcome to Maths, Statistics and Careers with Founders for Schools, which we are running to celebrate Maths and Statistics Day. My name is Neelam and I'll be hosting the session. And in this session, students will gain insight into careers which use the M in STEM. You will hear from inspiring role models this morning who have impressive and unique careers which all use maths, sometimes in unexpected ways. There are some questions coming up on your screen, so if teachers can answer those questions on behalf of students, that's going to be wonderful for us to see. And we're recording the session as well, and it'll be featured on our YouTube channel. So sit back and enjoy the presentations. We've got only half an hour and we've got lots to cover, so we're going to go straight into welcoming the speakers. So first of all, thank you to our guest speakers for volunteering your time this morning. I know everyone's really busy, but we really do appreciate it, and I'm sure the students and teachers watching today will appreciate it too. So we have Sritika Chowdhury, Caroline Wallbank and Joe Hammond. Apologies if I've mispronounced anything. And over to you. So what we'd love to know is, what is it that you actually do? If you can sort of define and break down your role at sort of a typical day for the students that are watching, and what problem is it that you're trying to solve through your work as well? And also just how did you get there? Where did you start off? How did you get there? What was your career journey? And just sort of everything in between, and just really kind of just speak to the students and give any advice as well that you possibly have. And students watching, you can ask as many questions using the chat function as well. We'll try to address those towards the end. Thank you. I'll hand over to Caroline.
Fantastic, thank you. Let me just share my screen. Hopefully you guys can see that. Fantastic. So thanks very much for inviting us to talk today. So I'm Caroline. I work at the Transport Research Laboratory, and me and Sritika and Joe are going to talk a little bit about some of the maths that we apply in our day-to-day transport research work. So a bit of background about me. I'm a principal statistician here at TRL. And that means that I carry out kind of statistical analysis and research to understand safety on the roads. So as a kind of, how did I get here? When I was about 5, I decided I was going to become a vet, and all my GCSE and my A-level choices were targeted towards becoming a vet. And then finished my GCSEs and decided that actually I didn't want to become a vet. I was going to go to uni and I was going to do maths. And I remember having a conversation with my dad, and he asked me, what are you going to do with your maths degree? And I said, oh, I'm going to go and become an actuary. And he asked me why, and I said, because they earn a 6-figure salary. And that was my logic. I was going to go to uni, I was going to become an actuary. And I went to uni and I did my maths degree, and I found I really enjoyed the statistics side of things, so I really focused on those kind of courses. And then a family friend got me a summer placement at TRL between my second and my third years of uni. And I loved it. It was really interesting work, really nice people to work with, and came out of uni, got a job at TRL working as a statistician. And then I've been there since 2011 now, so I've been here 10 years. Have had various roles in that time. I've taken on kind of line management responsibilities. I've taken on team leader roles. I've gained additional qualifications in my kind of chartered scientist and statistician. And here I am now as a kind of principal statistician.
Hi, my name is Jo Hammond, and I am a data analyst at TRL. So a data analyst, what do I do? Mostly I look at information, usually numbers and data, and use it to answer questions. And at TRL, those questions are about road safety. So how did I get to TRL, and what made me want to be a data analyst? Well, I didn't really have any ambitions when I was at school to be a data analyst, and in fact, I'd never even really heard of it as a job. But all I knew is that I liked maths, so I took it for A-level and further maths as well. But I didn't really know what I wanted to do, so I took a couple of quite different subjects as well, just to kind of keep my options open. Got to the end of school and realised really didn't like the other subjects very much, but I did like maths. So went to university, did a degree in maths, and again, didn't really have a plan. the plan was, I'll do a maths degree and see what happens. So I got to the end of my degree and still didn't really know. But I knew I didn't really want to go into banking or insurance or any of these kind of really big London companies, just because it all felt a bit abstract. I couldn't quite get my head around what they were actually doing, all these big numbers moving around, big amounts of money. I couldn't really relate to it. So I found TRL just through Googling jobs in the area I lived in. And I thought it sounded really interesting because cars and roads, I interact with them every day. And that's one of the things I really like about TRL, is that the work I do now, I can relate to real life. I can kind of see what effect it's having in the real world. So I've been at TRL for 4.5 years now. I started as a graduate statistician, and as I said, I'm now a data analyst. I work on loads and loads of different projects, but most of what I do involves looking at data about road traffic collisions and working out kind of what might have caused them and therefore how they might be able to be prevented.
Hi, everyone. My name is Shrutika Chaudhary, and I'm a statistician at TRL. So what do? I apply various statistical techniques to answer questions relating to road transport, just like Caroline said. So a little bit about my background. So I did my A-levels back in India, where I'm from. I didn't really know what I wanted to do, but throughout my schooling life, I really enjoyed maths and sciences. So I always knew I wanted to do something in STEM, but I didn't really know what. So while I was doing my A-levels, I decided I wanted to be an engineer. Why? Because all my friends were doing it, and I just wanted to do the same. But when I completed my A-levels, I realized I don't actually like engineering, but I still didn't know what I wanted to do. So I looked up all the subjects that were being offered at an undergraduate level and realized I like the sound of math, stats, and economics. I've never done economics before, so it'll be interesting. Let's find out. But during my undergraduate degree, I realized I really like statistics and I like how it's applied and it can solve real world problems. But I decided I wanted to study further. So I went and did a master's in statistics from the University of Warwick. When I was at Warwick, my professor told me about TRL, and she told me, she introduced me to people, and she told me how TRL helps government and you could solve problems. And that's what really fascinated me about TRL, is that whatever we do in our day-to-day jobs actually attempts to solve a real-world problem. And so I applied for a job at TRL, and I've been a statistician over there since 2016, so about 5 years now, and I'm quite proud to work there. So a little bit about TRL. TRL stands for Transport Research Laboratory. In very simple words, we do anything and everything relating to road transport. We're an organization of about 250 employees with a wide range of skill sets, right from engineers to scientists to data analysts, statisticians, psychologists, and we all work together to help government and other organizations create a safe and reliable transport system. I guess one of the key questions for this session is to understand what is the gender distribution in our organization. So currently we are around 30% female and 70% male in the organization, which is not really surprising because men are more likely to study STEM subjects. However, when I started at TRL, we were within our data team, there was only one male, and we were quite a female-heavy team. And even within our senior management positions at the moment, 3 out of 5 of them are female. So we've got, well, I personally have always had a lot of female role models within the organization, which has been really nice. So today we'll talk a little bit about a study that we were all part of years ago, and talk a little bit about how we applied math in that study. So this is quite a few years ago, DVSA wanted to change the practical driving test. Now, this is the driving test that most of you guys will hopefully be taking when you turn 17 to go and drive a car. So DVSA wanted to make that driving test safer for learner drivers. And one way of doing that was introducing the use of sat-nav within the test so that it mimics real-world driving and helps learner drivers get used to it. So in order to test whether this is actually safer, we needed to conduct a trial. So we recruited thousands of learner drivers and we split them into two groups. One is the group that did the old driving test, and the other group did the new revised driving test that was being proposed by DVSA. And so we recruited learners and asked them to complete 2 surveys, once before they passed their test and one a few months after they passed their test. Now, one of the ways we use math, and the simplest way we use math, is to look at crosstabs and look at distributions of people, because we want to understand that our sample is actually reliable and not biased. And this is by simply looking at percentages as shown over there. So we had the existing group and the revised group, and we looked at the percentage and distribution within each group to make sure that it is balanced and that there are no biases in there. Now hand over to Jo.
So yeah, what happened in this trial? How did we actually make sense of all the data that came from, you know, all these 2,000 participants to turn it into actual answers to our questions? So this table is what we call summary statistics. So this is kind of a really quick way to see, you know, put a number on each group and compare them. And we use just quite simple stuff, averages. So we've got a median in this table, so the median number of months spent learning to drive. So it's quite similar between the two groups, and mean as well. So we've got the mean number of hours spent learning with a driving instructor. And again, that's quite similar between the two groups. We also did some more complex analysis, so some statistical modelling using some maths that we'd all learnt in our degrees. So the statistical model was used an equation a little bit like the one there, but in a nutshell, statistical modelling is trying to work out what effect various factors have on a result. And our factors in this case were things like how long people spent driving, how many times they took their test, and our result that we wanted to see how it was affected was how likely people were to have a crash after they'd passed their test. So this modelling, actually, one of the results from it was that one of the factors we looked at was the amount of time people spend driving independently. So that's either following their sat nav or following signs. And the mathematical modelling we did showed that the more time you spend doing independent driving when you're learning to drive, the less you are at risk of having a collision when you've passed. So we did all this analysis, it's all very well, but we had to be able to present it to the other people who hadn't been involved in the project, so back to DVSA. And we use a lot of bar charts at TRL when we present our results, because they're really easy ways to present data. And this is an example of one from this project. So this chart shows answers to the question, how often did you drive using a sat-nav after you passed your test? And it shows the percentage of participants that answered in each of the different ways, all the way from always to never. And one of the reasons we use percentages quite a lot when we're presenting our results is because it's a lot easier to kind of say 15% of drivers used a sat-nav fairly often. You know, you can kind of get your head around 15%. Yeah, I know what 15% looks like. But if we said 100 drivers or 20 drivers or whatever used the sat-nav after passing their test, you're kind of thinking, well, 20 out of how many? Or, you know, is 20 a big number? Is it a small number? I don't know. So that's one of the things that we use quite a lot, those percentages, because it's really easy for other people to understand what we're talking about. So this particular chart shows that those people who took the revised test with the sat-nav, the orange bars, were more likely to say that they used a sat-nav after they passed their test. And you can easily see that because the orange is bigger than the grey on the left, and the grey is bigger than the orange on the right. So that's kind of a whistle-stop tour of what we did, but what's happened next? What was the point of doing it? And actually, so the revised test that we trialled is now the one taken by everyone in this country. So it'll be the one that you take when you learn to drive, which is really exciting as someone who worked on the project. But actually, all those crosstabs we made, all those bar charts, all that statistical modelling actually led to the result that this test is a good idea. It should be used, and now it has been rolled out across the whole country, and we were part of that. So exciting.
And I'm going to take over at this point and tell you a little bit about another project which I worked on when I actually first started at TRL. Just a slightly different application, similar analysis to what Joe was just describing. So I don't know if any of you guys have ever driven down the motorway network overnight and come across various sets of roadworks. But typically kind of short-term roadworks are carried out overnight because the traffic flows are lower. And prior to this project happening, actually, the kind of setup for the roadworks, for each set of roadworks is as is shown on the slide here. So in this diagram, you've got a kind of overhead shot of the road, and you've got vehicles travelling from the bottom of the diagram to the top of the diagram. And you can see the start of the roadworks here where these cones and blue signs are. So we've got the hard shoulder, which is this purple lane on the left-hand side of the diagram. You've got 3 lanes where the traffic is travelling, and then this blue line here represents the kind of central reservation, where you've got the division between vehicles travelling in one direction and vehicles travelling in the other. And for each set of roadworks, the signing configuration that was required was as follows. So you've got 5 pairs of signs, 1 installed on the hard shoulder and a second installed in the central reservation. And in order to install these signs, typically 3 guys come along in a roadworks vehicle. They'll pull over onto the hard shoulder and park by this 1 mile roadworks sign here. They'll get out their vehicle, they'll install this sign, and then they have to cross the carriageway with the sign, the stand, the sandbags in order to install the sign in the central reservation, cross back again. And they drive along the hard shoulder and they do the same thing 4 more times in order to install the signs in the central reservation as well. Now, for each of those signs, typically requires at least 8 carriageway crossings just to get 1 sign installed. So in total, these guys are having to cross the carriageway at least 40 times in order to get these 5 signs installed on the central reservation. I don't know if any of you have ever looked to see how big some of these signs actually are, but they are big. They're big, they're heavy, they're cumbersome. The guys who are out there installing them are doing this at night time. Traffic is lower than it is during the day, but speeds are typically higher. And they're obviously obscured slightly by the fact that they're carrying this big sign across the road. So it's quite a risky job. And the aim of this project was really to trial a setup to see whether we could get a setup for the roadworks which was less risky to the road workers and didn't require them to have to cross the carriageway carrying these massive, very big signs. So for this trial, I kind of used aspects of things that I'd learned at GCSE, at A level, and then kind of covered in more detail at university. And we had to design a robust experiment to test the effect of essentially removing signs from the central reservation. So we collected data both in the control condition, which is this one on the left, where you've got the current signing configuration for the roadworks that was approved for use at the time. And then the one on the right is the experimental condition that we then tested to compare that against. And the type of data that we were collecting here was we were collecting data on the number of vehicles in each lane at each of the sign points. So each of these 4 yellow wicket signs, we were collecting data about how many people were driving in each lane. And the aim was to understand if the point at which drivers moved out of lane 1, which is the closed lane up here, was similar between the control and the experimental conditions. So this chart kind of summarises, I guess, the key findings here, and similar to what Joe was talking about earlier, it's presented as proportions. So this chart's showing the proportion of vehicles in each lane at each sign point. So you've got the 4 wicket signs here, and the roadworks are at this end of the chart, so vehicles are travelling through the roadworks from the 800 yards to 0 where the roadworks start. And the key data here really is this lane 1 figure. So this is the closed lane, and this shows the proportion of vehicles in lane 1 at each of those sign points between the control condition, which is the blue line, and the experimental condition, which is the red one. And as you can see, the kind of trend of how people move out of lane 1 and into lanes 2 and 3 was very, very similar between the control and the experimental conditions. And we carried out statistical tests to confirm that there wasn't a significant difference in lane occupancy and how vehicles were behaving between the 2 conditions. And the one thing I would say about the maths in this trial, and what I actually had to do in terms of percentages and kind of averages and some of the simple statistical tests that I learned in my first year at uni, was relatively straightforward. But the thing that I found most challenging really was working with real life data. So this was kind of the first experience I'd had to collecting data from an experiment like this that's on road, and found that the data could be quite messy, and there's lots of data cleaning that you have to do before you can present a chart which looks fairly simple like this. And the really good news is that, similar to what Joe was saying earlier, this has got real world applications. So as a result of these trials, the technique where there was no signs on the central reservation side was approved for use, and that's out there being used by road workers for these short-term overnight closures now. It's resulted in a substantial reduction in the risk that they experience because of the fact that they don't have to cross the carriageway, and that's had no increase in risk to road users. So that's it from us. Does anyone have any questions that they want to pose to us?
Thank you very much. I think it's wonderful that you've demonstrated so lovely, so beautifully there that actually you're using maths every single day to protect our safety on the roads. And I think a lot of young people watching today will be quite surprised by that, actually, that you can use maths in many ways, and that is the purpose of these sessions. We do have a couple of questions, actually. We've got a little bit of time, so let's try and get through some. But thank you for that presentation. It was really nice and clear. But I would love to know as well, and we've got a question about it, how often do you present your findings, and are you ever nervous presenting your findings and using charts and data, or has that kind of come with confidence?
For me personally, it's certainly come with confidence. I think we do present our findings a lot. We present our findings quite frequently to clients, but also, I mean, we've all presented, I think, at kind of conferences and things to a much bigger audience. And certainly I'm not a natural presenter, I must admit, and I think it's certainly something that has definitely just come with practice, if you like.
And before we move on to the other speakers as well, S1, Mrs. Steele, welcome and thanks for joining. So they've been learning about mean and median. Are there certain times you would use mean rather than median? And can you maybe give an example of when? Caroline, do you want to take that one, and then we'll ask the other speakers as well?
Ooh,
or anyone else can jump in here. Stritika, maybe.
I guess sometimes we have to look at both because they can give a slightly different picture. So in the DVSA trial, we tend to look at distributions, and if it's, I don't know if people have been studying a normal distribution, depending on how people respond to things. And if the mean and median are quite similar, then we may tend to just present the mean. But if they're different, then we like presenting both the mean and median. But sometimes you need to give everybody the whole picture rather than presenting just one, because then often there'll be a question of, oh, but what is the median like? So it really depends on the type of data we've got and what distribution, which is again something that we learn in basic statistics. So it's a good way of understanding how this is all applied.
Thank you.
quite often with the median as well. I mean, we do a lot of work with kind of survey data, which typically can involve kind of collecting things on a strongly agree to strongly disagree kind of scale. So therefore, you've got kind of more ordinal type data. A median would potentially be more useful in that context, but mean potentially more so in other contexts.
Yeah, like if you're looking at speed, for example, we quite often will use mean if we're looking at speed or flow data, to say the mean speed on the road at this time was 50 or 60 or whatever it was. So we use mean in that situation.
And another question that I've actually thought of myself, but if you have any questions at home in classroom, sorry, please do ask. But we often, I think students often think that, oh, I don't need this and I'm not going to use this later on in my life when they're actually learning about mean, median, mode and other things like that. But you've mentioned statistical modelling, you've mentioned the median, that concept. What would you say to children and young people watching who might be thinking maths just isn't for me, I'm not going to need it later on in life? What advice or what would you say to them? Jo, should we start with you?
Yeah, I think I'd say that it crops up unexpectedly.
Yeah.
So I mean, I don't know if anyone doing, I think it might be in GCSE maths, has done compound interest, or where you apply percentages and year and year and year and you work out kind of percentage increase over a whole number of years all on top of each other. And I didn't really like that at GCSE. I didn't really understand it, but I've had to use it, and I never thought I was going to have to use it. But we were looking at percentage change in casualties over 5 years. And we had a 2% change in the first year, but then we had a 3% change on top of that 2% change, and we had to keep putting them on top of each other. And I was suddenly thinking, gosh, I did this at GCSE. I haven't thought about it for 10 years, and now here I am doing it again. So I think it'll crop up when you're least expecting it, and you'll suddenly remember, oh yeah, I do remember doing this, and actually now it's really useful.
Great, thank you. And I suppose the final question is, were the three of you, were you always confident at maths? I know you enjoyed it. Were you always confident and were you always good at maths? And any final advice for anyone who, again, may be lacking confidence in maths, maybe watching, the presentation, considering actually I would like a career like this, but not really sure where to get that confidence from? What advice would you give? Caroline, should we go to you?
Oh, advice. I think in terms of general advice, I think my general advice would be find something you love and pursue that, because I think if you've got an interest in it and you enjoy doing it, I think the math skills that you're learning at school, as Jo's already sort of hinted at, will come in useful. So work at it. I think we're all in the position where I confess to not knowing everything about maths, and I think there are points in my career and points at which I'm doing something that might be maths or stats related that I'm not 100% familiar with, and talking to Jo, Shritika, others of my colleagues really helps. So I think my advice would be kind of get that help and support when you're struggling with something, because then hopefully you can build on that and gain that confidence as you go.
Yeah, and also on the confidence front, I remember I did GCSE maths and I did pretty well, and I remember thinking, oh, I want to do A-level, but I'm not sure I'm good enough at maths to do A-level maths. And I actually asked my maths teacher, and she said, of course you are, of course you can do it. And so I think I didn't have the confidence in my own ability, but my teacher, who had been teaching me for the previous 5 years, kind of knew my capability a bit more and was able to give me that confidence. So I think my advice would be also, if you're not sure or you're not feeling very confident, actually talk to your teachers as well, because they've taught you, and they will be able to encourage you as well.
It's really good advice. Yeah, absolutely. Communicate those fears, communicate any sort of doubts that you're possibly having in your ability. And finally, Shritika, did you ever doubt your ability growing up around maths?
Well, I enjoyed math, but that being said, there were certain aspects like geometry I didn't really like. And I always thought, oh, but I don't like geometry. Do I need to pursue that? Do I still need to study that? And my parents really supported me, because my father also really enjoys maths. So whereas my mother absolutely hates it. She said, I can't stand numbers. So I had that different perspective growing up, but they supported my decision, and they made sure that I got enough practice in maths, because they realized that it is quite important in the future. Like my mum really struggles at the moment, and I help her from time to time. So I think it like Joe said, like Caroline said, you can either take support from your colleagues when you're grown up, or support from your teachers in school, or even support from your parents at home, and just practice, and that you may find something that you like and then go ahead with that. Like at university, I didn't like pure mathematics at all, but I like statistics, which is still a part of mathematics. And I decided that that's what I want to focus on. And that's where my skill set lies. So it's just practice and understanding that maths is very diverse, and there are lots of different bits to it.
Brilliant. Thank you. Practice, practice, practice. So thank you. We're sadly out of time, but thank you for the insightful discussions and for your presentation. That was really wonderful. I also want to thank the students and the teachers for joining us, and students and teachers, you will be emailed a short survey form after the sessions, so please complete those so we know how we're doing. But a final thank you to everyone for joining. Look out for the recordings. They're going to be featured on our YouTube channel and social media, and we have some more events coming up today as well, so keep an eye out for those, and hopefully we'll see you all very, very soon. Thank you again for your time, and have a good rest of the day.